In this video, I'm going to answer questions on page 68 and 70, and you can check your answer to see whether you got the correct answer for these questions or not. Question number 1 on page 68 says copy and complete the statements. Oxidation means, in part B says reduction means. We had three definitions for oxidation and three definitions for reduction. I can answer them here. So oxidation means, so we had three definitions based on the transfer of oxygen, transfer of hydrogen, and transfer of electron. Oxidation means gaining oxygen or losing hydrogen or losing electron. So the more complete definition is this one. Oxidation means losing electron, but you can apply any of them to answer your questions. On the other hand, reduction means, so you know that the reduction is opposite of oxidation. So reduction means losing oxygen gaining hydrogen, or more complete definition, it's gaining electron. So this definition is more complete. Okay, next part, it says oxidation and reduction always take place together. So you cannot have only oxidation or only reduction. You must have the oxidation and reduction together. Question number 2 says magnesium react with sulfur dioxide like this. So the reaction of the magnesium with sulfur dioxide is given. What is the product? Product is MgO. Okay, this is ionic compound. The name of that is magnesium oxide, and S is sulfur. So magnesium reacts with sulfur dioxide to gives you magnesium oxide and sulfur. It says copy the equation and use the label arrows to show which substance is oxidized and which is reduced. Okay, so I answer the question here. You can see what happens to the magnesium. It has gained the oxygen, so it is oxidized. Here is very clear because you have transfer of oxygen. And what happened to the sulfur dioxide? It's converted to the sulfur, so it means it has lost the oxygen. So this is reduction. Question number 3 says explain where the term redox comes from. The RED, or the red, comes from reduction, and ox comes from oxidation, because these two reactions happens together. Usually the oxidation reduction reaction is called redox reaction. Question number 4 says many people cool with the natural gas, which is mainly methane, CH4. The equation for its combustion is, so methane react with oxygen. You know what is the product. In previous chapter you have studied about that. Combustion of the hydrocarbon results in carbon dioxide and water if the oxygen is enough. This show that this is a redox reaction. So how can you show this is the redox reaction? Look at this one, CH4. What happens to the carbon? Carbon has gained the oxygen and lost the nitrogen, lost the hydrogen. So it means the carbon has oxidized. So this is oxidation happen here. And we say CH4 is oxidized. So when you have the oxidation, the other reactant must be reduced. So you can see oxygen here has gained the hydrogen. So gaining hydrogen, as I said, means reduction. So here we have reduction. So one of the reactants is oxidized, the other reactant is reduced. So we have a redox reaction. Let's go to the next question. Question number 5 says write down the equation for the reaction between magnesium and oxygen. So reaction between the magnesium solid at room temperature and oxygen is gas and it's diatomic molecule, so it's O2. Use the label arrow to show which element is oxidized and which element is reduced. Okay, magnesium can react with oxygen to produce magnesium oxide, MgO. So how do I know the formula is like this? I know that the magnesium right here, magnesium ion is Mg2 plus and oxide ion is O2 minus. So this 2 comes here, 2 goes here, it becomes Mg2O2, but we have to write the ionic compound in the simplest ratio, so it becomes MgO. So this is the equation. It is not balanced. On the right side here I have 2 oxygens, so here I put 2 to make the oxygen 2, but now at the left side the number of the magnesium becomes 2, so I have to add 2 here to make them balance. Okay, now everything is balanced in this equation. Okay, so the question says which element is oxidized and which one is reduced. So look at the magnesium. What happens to the magnesium? It has gained the oxygen. So obviously the magnesium is oxidized. So when one reactant is oxidized 100%, the other reactant is reduced. So we determine which one is oxidized, which one is reduced. Also, we know that the magnesium is converted to here magnesium ion Mg2 plus. It has lost 2 electrons, so it is oxidation. And what happened to the oxygen? Oxygen is converted to the oxide O2 minus. It has gained the electron. So this one proves also that the magnesium is oxidized and oxygen is reduced. Okay, let's go to the next section, section 4.2, and answer the question on section 4.2. Question number 1 says give a full definition for oxidation and reduction. So we had the definition. Oxidation means gaining oxygen, losing hydrogen, or more completely we can say oxidation means losing electron. And the reduction means losing oxygen, gaining hydrogen, or more completely we can say reduction is gaining electron. Question number 2 says what does a Hoff equation show? The Hoff equation shows either oxidation or reduction. So it only shows part of the equation. Okay? And we know that we cannot have only oxidation and reduction by themselves. So that's why we call them Hoff equation. Question number 3 says potassium and chlorine reacts to form potassium chloride. It is a redox reaction. Explain why. Okay, so potassium is K, it's metal, it's solid at room temperature, plus chlorine is diatomic molecule Cl2, it's gas at room temperature. So when they react with each other, the result is potassium chloride. You know this is the ionic compound. Potassium is K plus, chloride is Cl minus. So the product is KCl solid. Okay, it says explain why it is redox reaction. So you can see from here, okay, this is the ionic compound. So you have K plus and you have Cl minus in the ionic compound. You have cation and anion. So what happens to the potassium? It becomes K plus. It means it has lost the electron. So here you have oxidation. And what happened to Cl2? It has converted Cl minus. It has gained the electron. So this one is reduction. So that's why this reaction is redox reaction. Part B says, see if you can write the balance half equations for it. Okay, so let's write the balance half equation for this one. So I rewrite the equation here. So we have potassium, it reacts with chlorine, Cl2, and it produces an ionic compound, KCl. Okay, instead of KCl, I can write I have K plus and Cl minus. So first I wrote oxidation half equation. So in the oxidation half equation, potassium is converted to the K plus. For balancing, first we balance the mass. I have one potassium at the left, one potassium at the right. So the mass is balanced. Then I have to balance the charge. The charge on the left side is 0. The charge on the right side is positive 1. So how we can balance the charge? We balance the charge by adding the electron to the side which has more positive charge. So if I add one electron here, plus electron, this electron is negative and this positive, so the charge would be 0, same as the other side. So this is balance oxidation half equation. Now I want to write reduction half equation. Reduction half equation. Okay, so what do you have on the left side? I have Cl2. It is converted to Cl minus. Okay, let's balance this equation. The first step is to balance the mass. On the left side, I have 2 chlorine atom. On the right side, I just have 1. So if I want to make them equal, I need to put the coefficient 2 here. So now the mass is balanced. Let's go to balance the charge. The charge at the left side is 0. At the right side, the charge is -2. You have 2 chloride, each one of them is -1. So totally I have -2 charge at the right. So if I want to make them equal, I have to add the electron to the side which has more charge. Here is 0. I need to add 2 electrons here to make this side also -2, same as the other side. So this is the balance redox half equation. Okay, so the question asks for this one, balance half equations. But if you want to write the balance redox equation, okay, I want to write the redox equation. Redox equation contains both of them, oxidation half equation and reduction half equation. So I have to add these two half equations that I have here to make a redox equation. But I can add them only if the number of the electrons are same. Here I have 1 electron, here I have 2 electrons. So in this case, I multiply this one, the equation that I have here, by 2 to make the electrons same as the reduction half equation. When you multiply this one by 2, you have to multiply 2 by all the coefficients. So 2 times 1 becomes 2 here, becomes 2 plus 2 electrons. So now I'm able to add these two equations. So I have oxidation half equation. It says 2K gives you 2K plus 2 electron. And remember, in the oxidation half equation, always the electron appears at the right side. It must be like that. For the reduction half equation, I have 2 electrons plus Cl2. It gives you 2 Cl minus. And again, for the reduction half equation, electron must appear at the left side. Okay, now I am adding these two half equations to make a redox equation. So when I'm adding these two equations, the electron at the left side and right side cancel out each other. The rest of them I just add them. So I have 2K plus Cl2. it gives you 2K plus and 2Cl minus. This is the balance redox equation. Okay, let's go back to your book to question number 4. It says, bromine displaces iodine from a solution of the potassium iodide. Write the balance half equation for this reaction. Okay, so it says bromine Br2 diatomic molecule plus displaces iodine from solution of potassium iodide. So you have solution of potassium iodide. The bromine displaces this one. So what happens if it displaces this one? Iodine comes out of the solution, it becomes I2 plus KBr. This is the equation that I have here. Okay, so one more time, what happens here? Bromine displaces the iodine in Ki solution, potassium iodide solution. So when it goes into the compound, it forms potassium bromide instead of potassium iodide, and iodine comes out. It's diatomic molecule, so it makes I2. Okay, so in part A, it says write the balance half equation for this reaction, add the half equations to give the ionic equation for the reaction. So we do the same thing that we done for the question number 3. So I answer the question here. What do I have here? I have Br2 is reacted with Ki to give me KBr plus I2. Okay, so always in this type of the equation, find the ionic compound. Write them as a cation and anion. Two ionic compound I have here, Ki. The cation is K plus, the anion is I minus. On the right side, I have KBr. The cation is K plus, the anion is Br minus, bromide. Okay, now determine what happens to bromine. The bromine is converted to the Br minus. It means it has gained the electron, so it is reduced. And what happens to the K plus? It remains the K plus. So nothing happens to the K plus. What happens to the I minus? I minus is converted to I2. It has lost the electron. So it means it is oxidized. So I can write these two half equations. First I write oxidation half equation. So in oxidation half equation, I minus is converted to I2, and then I have reduction half equation. In reduction half equation, Br2 is converted to Br minus. Okay, these two half equations are not balanced. Let's balance them. Let's start with oxidation half equation. Here on the left side, I have one iodide. On the right side, I have two. So for balancing the mass, I must add 2 here as a coefficient. So now their mass is balanced. Now I have to balance its charge. The total charge at the left side is -2. I have 2 iodide. Each one of them is -1. So when I have 2 iodide, the total charge at the left becomes -2. At the right side is 0. So I have to make the charge equal by adding electron. In which side I have to add the electron? Obviously at the right side, because if I add 2 electrons which are negative charge at the right side the charge would be -2, same as the other side. And the electron must appear at the right side because I'm balancing the oxidation half equation. No, for this oxidation half equation the mass is balanced, the charge is balanced. Let's go to the next one, the reduction half equation. The first step is to balance the mass. On the left side, I have 2 bromine. On the right side, I just have 1. So I need to add the coefficients 2 to make 2 bromine at the right side. Now the mass is balanced. It's the time to go to balance the charge. At the left side, the charge is 0. At the right side, the charge is negative 2. So I have to make the charge equal. I can do it by adding the electron to this side. How many electron I have to add? Yeah, the charge is negative 2 here. Here is 0. So if I add 2 electrons, the charge on the left side also becomes negative 2, same as the right side. Again, the electrons appears at the left side of the equation, and it must be like that because we are balancing the reduction half equation. Now, if I add these two balance equation, I can get a redox reaction. So redox reaction. Redox, sorry. Okay, so for redox reaction, the number of the electron at the left side and right side for reduction and oxidation must be equal. You can see in this one, these two are equal. So I just add these two equations. These two electrons cancel out each other. So what remains at the left side, you have 2I minus and Br2. So I have 2I minus plus Br2. And what do I have at the right side? You have I2 and 2Br minus. I have I2 plus 2Br minus. This is a redox reaction. You can check the redox reaction to see if the mass and charge is balanced or not. So you have 2 iodine here, 2 iodine at the right side. You have 2 bromine at the left, 2 bromine at the right side. So their mass is balanced. What about the ions or the charge? 2 negative charge here. This one doesn't have the charge, so 2 minus at the left. At the right side, this one doesn't have charge, 2Br minus. So the total charge at the right side is also negative 2. You can see their charge is also equal. So this is the correct redox equation. Okay, so we have done answering these questions. So you can check your answer, see if you got the correct answer or not. And if you have any problem in these questions, you can send me the message. I will answer to you about these questions.